Check this out, y'all. I don't want you back, don't call me. I keep saying next time and I'm saying in your life. 깊어진 밤 집요하게 벨이 울려 It's your calling 고집스럽고 지독하지 그게 바로 너 스티커 너는 쉽게 포기 못해 그 성질 버리지 못해 온종일 내 이름만 수치해 내 흔적들을 찾아 핥아대 내 아침을 망치곤 해그 패턴은 뻔해 관심 꺼줄래 I know where you came from 그대로 나의 shawty 사라져줄래 저리 Don't think about calling 넌 못 버티겠지 집착뿐이겠지 나처럼 잘한 사람 없을 거니까 너도 참 피곤했지 전부 꾸며 대니 머릿속 꽤나 어지러웠을 거야 미쳤어 넌 You don't know you waste my time 네가 봐 넌 최악이야 When I hit your call 끝났어 너의 love Don't worry now 사랑하면 보내줘 Don't worry now 계속 말하잖아 Next time 넌 없어 in your life 네 사랑 난 이제 아니야 지워 날 잊어버려 제발 난 널 몰라 So 네처럼 하지 마 Think of all your trash 진짜 늦었다니까 널 믿지 않아 you know why 날 속였다는 걸 알아 속인 걸 알아 비극은 왜 사랑의 몫인데 슬픈 에픽 속 그 끝을 보고 있네 넌 못 버티겠지 집착뿐이겠지 나처럼 잘한 사람 없을 거니까 미쳤어 넌 You know you waste my time 네가 봐 넌 최악이야 When I hit your call 끝났어 너의 love Your love Don't worry now 사랑하면 보내줘 So bad Don't worry now 계속 말하잖아 Next time 넌 없어 in your life 네 사랑 난 이제 아니야 지워 널 잊어버려 제발 난 널 몰라 So 네처럼 하지 마 아직 같은 꿈 속에서 포기 못했니 I'll never pick up 지워버렸어 I'm gonna save my life For the next call Sorry, the number you have called has been disconnected 끝났어 love 사랑도 못 잊나 사랑했다면 돌려줘 난 찾을 거야 love 더 아름다운 지독했던 너와 나 잊을 수 있는 계속 말하잖아 Next time 넌 없어 in your life 네 사랑 난 이제 아니야 지워 날 잊어버려 제발 난 널 몰라 So 내게처럼 하지 마
I promise to tell the truth and nothing but the truth.
Check this out, y'all. I don't want you back, don't call me. I keep saying next time and I'm saying in your life. 깊어진 밤 집요하게 벨이 울려 It's your calling 고집스럽고 지독하지 그게 바로 너 스티커 너는 쉽게 포기 못해 그 성질 버리지 못해 온종일 내 이름만 수치해 내 흔적들을 찾아 핥아대 내 아침을 망치곤 해그 패턴은 뻔해 관심 꺼줄래 I know where you came from 그대로 나의 shawty 사라져줄래 저리 Don't think about calling 넌 못 버티겠지 집착뿐이겠지 나처럼 잘한 사람 없을 거니까 너도 참 피곤했지 전부 꾸며 대니 머릿속 꽤나 어지러웠을 거야 미쳤어 넌 You don't know you waste my time 네가 봐 넌 최악이야 When I hit your call 끝났어 너의 love Don't worry now 사랑하면 보내줘 Don't worry now All your trash, all your trash. 진짜 늦었다니까. 늦었어. 널 믿지 않아, you know why. 날 속였다는 걸 알아. 속인 걸 알아. 비극은 왜 사랑의 몫인데 슬픈 에픽 속 그 끝을 보고 있네. 넌 못하겠지, 집착뿐이겠지. 나처럼 잘한 사람 없을 거니까. 미쳤어 넌. You know you waste my time. 누가 봐 넌 짜야. When I hate you come. 끝났어 너의 love. Your love, your love. Don't worry now. Don't worry now, no. 사랑하면 보내줘. So bad, so bad. Don't worry now. Don't worry now, no. 계속 말하잖아 next time은 없어 in your life. 네 사랑 아끼지 않냐. 지워 널 잊어버려 제발. 난 널 몰라. 손 위에처럼 하지 마. 아직 같은 꿈 속에서 포기 못했니. I'll never pick up. 지워버렸어. I'm gonna save my life for the next call. Sorry, the number you have called has been disconnected. 끝났어 love. I said I don't want you now. 사랑했다면 보내줘. When I hate you call. 난 찾을 거야 love. My love, my love. 더 아름다운 Don't worry now. 지독했던 너와 나. So bad, so bad. 잊을 수 있는 Don't worry now. 계속 말하잖아 next time은 없어 in your life. 네 사랑 난 이제 아냐. 지워 날 잊어버려 제발. 난 널 몰라. 손 내게 전화하지 마.
빙빙도니 안 놓여 너의 떨림 미로소 끝끝에 넌 이제 빨리 뭐해 계속되는 멈지 Te amo I'll give you more I'm up here say yeah 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 따라와 faster yeah 후후를 뱉어 so hard 내 방식대로 짚고 나가 더러운 시선 신경 쓰지 마 미친 척 밟아 let's go on a ride Get on my bike let's go Get on my way 보여줄게 how I like it Get on my way That goes like vroom 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 Get on my way 고개를 들어 넓어 face Get on my way That goes like vroom 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 I'm getting higher You're tripping lower And when I say it's done It's freaking over And I write it You like it when I write it I write it Give me that My sweat dripping down my back I got ice decorating my neck Be the strongest thing, don't miss it Cause I'm the baddest queen I'm sicker than all them gossip and Loki's don't bring me no fun Come on, I'll slay it from tip of my tongue You wanna know and know what she likes Sit back and watch me ride I'm up here, say yeah, yeah, yeah 따라와 faster, yeah 후후를 뱉어 so hard 내 방식 그대로 짚고 나가 더러운 시선 신경 쓰지 마 미친 척 밟아 let's go on a ride Get on my bike, let's go Get on my way 보여줄게 how I like it Get on my way That goes like vroom 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 Get on my way 고개를 들어 넓어 face Get on my way That goes like vroom 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 I'm getting higher You're tripping lower And when I say it's done It's freaking over And I write it You like it when I write it I write it Give me that oh, yeah Write it You know how I like it Write it You know how I like it 설렜던 그 눈빛 타오르는 공기 Again alright with me 벅차오른 순간 몸을 숙여 다시 Together 1, 2, 3 Get on my way 보여줄게 how I like it Get on my way 빨라 그 순간부터겠지 Do it, baby it's okay 세상을 가진 것 마냥 이기적이게 그냥 원해주는데 그리워서 되는데 Make it right till I die baby ow 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 난 거기까지만 네 눈이 올라가는 소리야 여기까지 들려 쉬워하기엔 너무 빨라 알잖아 wait for it 우리 미친 듯이 사랑하고 미친 듯 입을 맞추고 미친 듯 어려움을 들어 우리 미친 듯이 사랑하고 미친 듯 입을 맞추고 미친 듯 꼬리를 흔들어 I'm much of a dream girl but I'm a dream girl 물음표 그만 좀 물어대 네 마지막 말에 꼬리치면 나 거기까지만 Do it, baby it's okay 세상을 가진 것 마냥 이기적이게 그냥 원해주는데 그리워서 되는데 Make it right till I die baby ow 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 난 거기까지만 네 눈이 올라가는 소리야 여기까지 들려 쉬워하기엔 너무 빨라 알잖아 wait for it 우리 미친 듯이 사랑하고 미친 듯 입을 맞추고 미친 듯 어려움을 들어 우리 미친 듯이 사랑하고 미친 듯 입을 맞추고 미친 듯 꼬리를 흔들어 꼬리를 높이 세워도 예민하게 꼬리를 높이 세워도 예민하게 난 거기까지만 네 눈이 올라가는 소리야 여기까지 들려 쉬워하기엔 너무 빨라 알잖아 wait for it 우리 미친 듯이 사랑하고 미친 듯 입을 맞추고 미친 듯 어려움을 들어 우리 미친 듯이 사랑하고 미친 듯 입을 맞추고 미친 듯 꼬리를 흔들어
Hello, good afternoon.
Good afternoon, sir.
Oops. Can you guys hear me?
Yes, sir.
Okay. We have quite a lot of topics to discuss today, so I plan to start as early as possible. So yeah, thanks Nicole for helping me. Just let your classmates in when they log on, I guess. But we'll start with the session. You can tell your classmates that if they miss something, they could just refer to the recording, which I will be posting on Canvas as well. Okay, technical check. Can you hear the music? Yes. Okay. I guess the most important thing here is the question number 2. For those who answered no and nani, okay, please upload your presentation materials on Canvas. I opened an upload link there. So whatever you presented, your PPT or videos, you can upload it on the Canvas assignments tab, okay? Or you can also just paste the link there if you save it on a Google Drive or whatever, okay? Para isang upload na lang. Right? So just upload it there for documentation purposes. But other than that, thank you for your preparation. Okay, thank you for your presentation as well. Last week and early this week pala kayo, no? Early this week. So yeah, we enjoyed the sessions. There were quite some tricky questions along the way, but well, that's the point of that's the sense of making decisions in an organization. So there will be a lot of questions when you face the C-levels, the board members, right? So the idea there is really to challenge your idea, because when they start investing on your ideas, they will be, of course, spending money and they want something in return, okay, from the stakeholder side. So they have to make sure that your idea is solid from the conceptualization, the target market, the value proposition, the financials, although we didn't discuss that really in detail, but at least you get an idea on how it's done, right? Yeah, so now, okay, for the week 3, okay, I'm not sure if you have come across the contents, although I updated also, I added more pages in Canvas regarding week 3, so just check it out. But the point of week 3 is really about data warehousing, and data warehousing is where is how business intelligence started. Okay, the point of data warehouse is to consolidate uh, data within the organization. Okay, so for the purpose of reporting and analysis. Okay, so before I explain everything, okay, let me show my slides. Sayang naman yung pinrepare ko. Okay. All right, so I won't be discussing in detail again what I posted on Canvas. So just go through them. There are also some checkup quizzes. One of them is actually by group. So just assign one person who will submit your responses, and then that's good. Okay, you don't have to think about sir, I have a missing grade from my end. If you're not the one who posted your quiz, you will probably see that. Okay, basta by group yung isang checkup quiz. Okay, para to save time and effort as well. All right, let's go through a high level analytics framework. Okay, the point what we have here is we have entry systems. They are usually called systems of record, or OLTP, online transactional processing. Basically, the point here is to record transactions or data writing. Okay, so from cashiers, they record your sales, your transactions, and then they are stored in an intermediary database, which is called the operational data store. Now, in operational data store, all of these data are technically raw. Okay, whatever is in those databases, those point of sales or POS databases, are directly dumped into the operational data store. So you can see duplicates of data. You could see a lot of transactions. You might also see dates with different formats. Kasi if branch A has different POS provider than branch B, okay, there are tendencies that they have different system designs. So they record transactions differently. Okay, so they dump everything together on ODS, or operational data store. That's not the end yet. Okay, for some small medium enterprises, they consider this as a data warehouse already. Okay, maybe because the data is already clean, they designed it properly from the source systems themselves. Na ganito natin sa store yung data. Okay, but for most cases, especially for mature organizations that have started probably without the current technology yet in data cleansing, in data integration, most likely the ODS will store the lots of data, and it can be considered as dirty data yet. Okay, now from the operational data store, okay, let me use my pointer. You can see my screen naman, no? Please let me know if there are any issues. Okay, now the process of moving data from one source to a target, in this case, we have the ODS as the source and the data warehouse as a target, is called the ETL, or the extract, transform, and load. And by the name itself, basically it extracts the data from the source, it transform it so that it's cleansed. Okay, you can clean the data, you can remove some redundancies, you can unify the date formats, the product names, you can unify them before it gets loaded to the data warehouse for reporting purposes. Okay, so that's the main job of the ETL tool, or ETL job, or ETL jobs, right? Now in data warehouse, okay, as the name itself, warehouse, tambakan talaga siya ng data. Okay, so this is where we actually, and usually for data warehouse, it's usually designed already, cleansed already for reporting purposes, but also it can still be divided into data marts. Okay, the data marts are smaller versions or smaller copies of the data warehouse. Basically, the difference between a data mart and a data warehouse is that for data marts, there are business owners. So for example, um, the finance data mart is owned by the finance department. The marketing data mart is owned by the department. Okay, so there's ownership from the business side. Whereas data warehouse is usually owned or is usually owned, not really owned. Okay, it's usually under the responsibility of the IT team. Okay, but the IT team, they simply just manage the design, the implementation, making sure the data warehouse runs as smooth as possible. They don't own the data. Okay, so most likely the business owners will argue that, hey, I own the finance data because we are the finance department, blah blah blah. Okay, so there are those some sort of there can be those political tendencies within when it comes to data governance. But the point is, data warehouse managed by IT, data marts owned by business users, and both of them actually feeds in to the reports, the dashboards, the analysis done by the C-level executives. Okay, that's a high level. This is the some sort of a level one, level two, level one, I guess, of that graph or of that figure. So we have here the different data sources. You can have your enterprise resource planning, legacy systems or old systems. It could be the point of sales from our example. It could be other transactional systems, or it could be flat files as well, CSV files, Excel files. It gets uploaded to the data warehouse using the ETL process. Okay, so these are the different transformations that could be done. Okay, from selecting which data sets, extracting them, transform, cleaning it, integrating if there needs to be some joinings. Okay, let's say for example, we need to combine the finance data in ERP with the sales data in POS. Okay, it can also be done in the ETL process before it gets loaded to the data warehouse, right? So in the data warehouse, there are also different operations inside. There are also different operations, and they can be pushed to different data marts for marketing, for operations, for finance, etc. Or there could also be a no data mart option, and both of them are used for different applications, all right? So if it's not evident yet, okay, the difference between an operational system and a data warehouse. So for operational systems, it's basically running the organization. So you take the orders, you sign up customers. It's the actual business process. Okay, so let's say your process really is to register. One of your processes is to enroll your users into your service or enroll them into your market loyalty program. Then that's part of the operational side or the operational systems. Whereas in data warehouse, we watch these engines, these wheels of the organization. So we count the new orders, we ask new customers why they sign up. Okay, we look at their complaints, we see if production can meet the demand. Okay, so it's really from reporting or perspective. Okay, if you compare it with the car, okay, operational systems, of course, is when you kick the pedal. If you're driving manual, you play with the clutch. But the data warehouse side is the dashboard itself. You see your speed, you see your gas meter, you see your engine temperature, and so on. Right. So that's the difference between operational systems and a data warehouse. Now, I also discussed this, okay, the characteristics of a data warehouse, but let me just go through it very lightly. Okay. First is that it usually talks about something. It's subject oriented. Okay. The models in a data warehouse usually talks about something. So for example, and usually these are business processes. Okay. So for example, we have a model in a data warehouse which talks about sales, and basically that just talks about sales, which is coming from the sales process. One data model could also talk about inventory, which describes what is happening in the inventory process. if you've of course I will go through some of these business processes later. Okay, but if you have taken some operation opman classes, okay, you probably have an idea already what I'm talking about. But I'll give also a very high level business process later. Okay, so that's a subject centered. So we talk about something. Okay, next is integrated. As you can see from the previous diagram, okay, if we go back here, okay, we can actually integrate different data sources. Okay, an example I mentioned earlier is when combining finance data with sales data, or more commonly sales data and inventory. Because when customers buy something, okay, we also want to know how much products do we have left. Okay, so we actually integrate those two data to have a picture of how our stocks flow in our company. Okay, so there's the data warehouse should be able to integrate these different scenarios or business processes. Okay, another aspect which is very important for data warehouse is time variant. Again, tambakan ng data. Okay, when for some if C levels would run a strategic meeting, okay, or they will go for budgeting or planning, they will need to look at historical data. Okay, so given that, to know which ones are the historical data, we need the time aspect in our data warehouse. Hence, it's time variant as well. This needs data warehouse needs to have a time horizon so that we could easily explain the data across a time axis. Okay. And lastly, it's non-volatile. So the goal really of data warehouse is that it's for data pulling or data pulling, basically extracting data for analysis. And if they change very often, then we're not seeing the real picture of the organization. Okay, imagine if you are the operations manager of the organization, you see the sales performance for yesterday, but that we are above budget. So good, we're actually performing well. And then another update comes in for the next day, and you see the sales for that day actually decreased. So what are you going to report? Did we perform well on that day, or did we actually perform poorly on that day? So the idea of the data warehouse is that the data should not change as much as possible, and what changes are the descriptors only. Okay, so what's the surrounding descriptors, okay, or the data that describes a specific measure or numerics, right? So that's the four characteristics of a data warehouse. Now we are going to how do we actually design a data warehouse? Okay. And usually designing this principle of designing data warehouse really helps when it comes to making reports or dashboards. Okay, because when someone asks you to create a report for this specific scenario, give me the sales report, let's say. Basically, you will trace it back. Okay, for a sales report, what do I need to be able to come up with a sales report? I need this, and I need the timetable. Okay, then from that, you also go back how to integrate these different tables before you could actually come up with a sales report. Okay, so in that way, you could see the design process, or you could have the design process behind your mind and see how it actually traces back into the actual sources, right? So that's a good thing. That's a good skill as well for a BI analyst to have. Okay, enough about chit chat. Dimensional modeling definitions. It refers to the logical design of a data warehouse, and its objective is user understandability, query performance, and resilience to change. Okay. First is user understandability. Okay. Usually, dimensional modeling is performed with business analysts. Okay. Given our data mining process, usually data understanding and business understanding goes side by side, right? So the business users also need to understand what is going on in that architecture. So That's one goal of dimensional modeling. Another is query performance. The goal, because we are actually pulling out data, large amounts of data from the data warehouse. This dimensional modeling will help us perform that process or querying in a more efficient or faster manner. And lastly, as I've mentioned earlier, the data should should not have a lot of changes, so it should be resilient to change. Okay, there are two main parts in a dimensional modeling, which is the fact table and dimension table. Okay, the fact table is the primary table in the dimensional model. It's the star, okay, because it has the numeric performance measurements. Okay, if we're talking about the sales, it has the sales data. If we're talking about inventory, it has inventory data. Okay, and most of in the fact table, each row in a fact represents a business measure. Okay, or usually it represents also a transaction, a specific transaction. Okay, and most of the facts or useful facts are numeric. Okay, actually not most useful facts. A lot of facts or all facts has to be numeric and they need to be additive. But later on, we will also discuss some types of facts that are not additive in nature, meaning we cannot aggregate them by simply adding them all together. Okay. Next one is dimension table. Basically, these are the descriptors of the facts of the business. Okay, so if we have the sales let's say our sales is 10 pesos. Okay, the dimensions will put more insights into that 10 pesos. It could be the product. Okay, we sold 5 boxes of milk for a total of 10 pesos. Okay, it could also have a customer insight. We sold 10 boxes to Juan de la Cruz at the total cost, at a total price of 10 pesos, right? So those are the dimension tables. Okay, now for the process of designing them, we have these 4-step dimensional design process. One is to select a business process to model. Second, declare the granularity. Later, I'll discuss that. Choosing the dimension that apply to each fact table and identify the facts that will populate each row in the fact table. Okay. Just to give you an overview, or if you haven't seen yet on Canvas, the activity for week 4 is will revolve around this. Okay. Actually making a dimensional model for your own metrics. Okay. So you could capture this, okay, or I will also post a recording on Canvas. Okay, but this is the high level overview, okay, of what needs to be done for the succeeding weeks. All right, so now let's go for each process, each step one by one. Okay, when selecting a business process, okay, just a basic definition of process: natural business activity performing an organization. Okay, it could be raw materials purchasing, it could be order capturing, stock shipment, moving goods from one place to another. That's also a process. Invoicing, inventory, or if you want to go more financial, the general ledger is also as an example of a process. Okay, sales is a process. Procurement is a process. Okay, so you can select a process. You need to select a process first before you start building your or designing your model for the data warehouse, right? Okay, for selecting a business process, when it comes to your project, okay, you would need to see how or which business process will capture your metrics or KPIs. So, for example, if you are targeting to, if your measurement for success is number of customers that stayed in our application or stayed with us for 10 months, for example, then that's another process. That is customer retention process. So you need to identify what process do you want to focus on. Okay, just select one metric, select one process in your organization, in your business ideas, and then you can focus on that. Now the step 2 is granularity. Okay, declaring the grain. Okay, specifying exactly what an individual row represents. Okay, so it answers the question, how do you describe a single row in a fact table? Okay, maybe I could give examples to make it much clearer. Okay, for example, a daily snapshot of inventory levels for each product in a warehouse. Okay, so we are actually dealing with that amount of detail. Daily data, inventory levels for each product, okay, in a specific location. Okay, that's the level of detail that we have for our model. Or it could also be, instead of daily, we could deal with hourly sales of each branch. Okay, so if we look at the data and someone asks us, how much uh, detail or how much granularity do we have in your data? Oh, we could actually provide hourly sales of, we could actually provide hourly sales for each branch. Okay, that's a type of granularity. Another one is monthly snapshot for each bank account. Again, monthly level of data, which means that if you capture it monthly, you cannot actually go weekly or daily. Okay, that's the most detailed or most granular that your data model can accept or can provide. Okay. Now there are pros and cons in dealing with less granular or more granular amount of data. Okay. Less granularity could save you computing resources. Okay. Imagine, instead of dealing with 365 rows of data, let's say you have daily sales, you only store 12 rows of data because you only capture monthly sales. Okay, that's how it could actually save up some computing resources. But again, the catch with that is that we're missing some details. If I am looking at the seasonality of or the trend of our sales, this doesn't help me. The monthly data doesn't really help me. I need to know up to at least weekly level or quarterly level to be able to understand when are the peaks in our sales, right? So now you need to go more granular. Okay, being more granular would provide you so much insights that technically, if you have the most granular information available, or most granular data available, you could actually answer all questions above that. If you have, let's say, the sales transactions up to the second level, you could answer hourly insights. You could get daily insights. You could get weekly insights. You could get monthly insights. Okay, that's the amount of information you can have from that very granular data. But again, if we go down, how many seconds do we have in a year? 525,600 minutes pala yun. Okay, let's go with the minutes. 525,600 minutes. Okay. That's the amount of data that you have to describe the entire year. Okay. Compared to, let's say, 12 months or 12 rows of data. Okay. So again, you have the drawback, more granular, more information, but also would require more resources, more efforts. Less granular, okay, less information, but also will consume less computing resources. Okay. Now, in some real world cases, they actually store different levels of granularity. They will store monthly data, they will store weekly data, they will store daily data, they will store hourly data. Okay. So that when me as the business user only needs monthly data, okay, I don't need the hourly, I don't need the weekly, I only need monthly, then the computer will only consume what is needed for a monthly data processing. If, let's say, another employee would need to go down to hourly, then that's the only time the computer will have to spend so much resources to build those hourly data or hourly insights. So there's like a middle ground in doing that. But also with the advent of more powerful computers, it's becoming more it's becoming cheaper and more practical to store really granular data. Okay, but it really depends on the situation of the organization. Okay, I talked so much about granularity, but hopefully you get the point on granularity. If you have any questions, feel free to type it in chat. Okay, so I can go through them later after the session, or I will also upload or put up a discussion thread on Canvas, and then you can just throw in your questions there. Okay. Now, the next one, you define the business process, you define the dimension. you define the granularity. Now you need to define what dimensions you want to include. Okay. It answers the question, how do business people describe the data that result from the business process? Excuse me. Okay. So you could think of it as which color goes on each side of the Rubik's Cube. Well, this isn't a cube, but yeah, you still have to select which colors that goes along with what side of this machine device. Example is date. Okay, of course we need the time dimension, so you need to have a date. Okay, it could be the product dimension, it could be the customer dimension, it could be the transaction type dimension. So how does this go? So for example, if you're storing sales data, you could actually describe them from these different angles, from these different dimensions. Describe the sales by date. You could describe sales by product, sales by customer, sales by transaction type. Okay, those are the dimensions that we are looking at. And lastly is, what facts are we really storing? So what are we actually measuring in this process? Okay, again, the facts should be numeric, they need to be additive, okay? And of course, they need to fit in the grain that you actually set. Okay, let's say if you set the grain of the fact table to be daily, but apparently you cannot capture daily data, then there's no sense, right? If the granularity of your table is monthly and you have daily sales data, then you could simply transform that and aggregate them by month and then push them to the fact table. Easy. Okay. So again, you need to identify the granularity first and then identify, and then that's when you can decide whether your facts could fit into that granularity. Okay. Those four processes, okay, of course, typical with any process, you could mix and match them depending on the situation in your organization. Okay. Now, those are the different processes, okay, on how to actually come up with a data model for data warehouse. Okay, now let's go with storytelling. Okay, storytelling. Okay, I'll give an example of an insight that can be provided, that can be extracted from a data warehouse. Okay, let's disregard data privacy first. Okay, this is just a theoretical example. Juan de la Cruz bought 2 boxes. Wrong grammar. Bought 2 boxes of Chucky milk for 150 pesos last March 1, 2021, 4:19 p.m. at 7-Eleven Ateneo branch using GCash. Okay. If you think from a fact and dimension perspective, from a multidimensional modeling perspective, you could easily identify which ones are the facts and which ones are the dimensions. Okay. But of course, since it's probably your first time dealing with those concepts, okay, I'll help you with that. Okay, so I highlighted a few things here, okay, a few words or parts of the story which actually corresponds to whether it's a fact or a dimension. Okay, now there is what we call the 7 W's of data warehouse design, okay, which actually talks about a user story. It's not all W's, okay, but we're not counting. This is not a counting class, I guess. But let's put it that way. We have 7 W's: the who, the what, the when, where, how, and how much. Okay, and I put some color correspondence, okay, to identify which ones corresponds in that sentence. Okay, the who is Juan de la Cruz. What is the boxes of chocolate milk? Okay. When, March 1, 419, where, 7-Eleven Ateneo branch, how, GCash, and how much is 2 and 150. Okay, so here, these, is it 7, 1, 2, 3, 4, 5, 6, it's just 6. Okay, medyo fake news ata yun na. Anyway, the rest except how much, okay, usually corresponds to the dimension, okay, dimension tables, whereas the how much corresponds to facts in the fact table. Okay, that's the easy way to deal with it. All right, now we will talk about some sales, some business processes. Okay, the first business process that I want to discuss is the sales process, and you could think it very very simply. Just think of it like when you're purchasing something at a store. Okay, so it's as easy as that. Okay, I don't need to lay down the specific processes in the sales process or specific steps in the sales process, right? So think of it when think of the time when you actually purchased something. Okay, now from a data warehouse perspective, this is an example. Okay, just an example. Okay, there could be more information, it could be less, depending on the capability of the organization to record those data. Okay, so we have here the sales fact table or transaction fact table. Okay, it stores the post transaction number, sales quantity, sales amount, cost, and gross profit. That's basically just sales minus cost, right? So these are the different things that a POS could capture already just by punching your items or when you pay those for your transactions, for your groceries. And usually this is actually connected to different tables or dimension tables. The date dimension, okay, which describes the dates. The store dimension describes the stores. Product dimension, you have which describes the products. And sometimes, if of course for marketing scenario, they need to know whether their products, their marketing campaigns are performing well or profitable. Then we need to tag each transaction to a promotion dimension, right? So when we talk about date dimension, okay, the goal here is to actually define what does January 1, 2002 mean for the organization. Okay, it could also break down the data. Okay, you for this January 1, 2002, okay, you have the month, day of the week, year. Okay, if you're using a calendar, if your company uses calendar year, then you just simply follow the calendar. There are companies who would use fiscal year, okay, which means that they have a different accounting calendar. Okay, there are some companies who start their accounting calendars or fiscal calendars at September. Okay, that means September 1 is their day 1 and not January 1. Okay, so that also can be defined in the dimension table to see today September 1. Okay, that's the calendar date, but this is actually our day 1. Okay, as an organization. So that's a fiscal calendar. Okay, so that can be defined in the date dimension. Okay, this is an example, okay, of the data inside the date dimension. Okay, you can have a date, the full date, day of the week, calendar month, year, and so some companies would need the holiday indicator or weekday indicator for the reason that they want to understand the sales performance between holidays and non-holidays, weekdays and weekends, and also for the Philippine setting, paydays versus non-paydays. Okay, that's also another thing that you can tag here. You can just add one column here and say payday indicator. Okay, you can do that. Okay, product dimension technically describes what the products are. Okay, so earlier in our example, we mentioned 2 boxes of Chucky milk. Okay, so the units could also be part of the product dimension, how we count them. It could also, the brand can also be part of the product dimension, okay, which for the milk, because you could have different milks, right, in the grocery, and you also you would want to see whether the entire milk category is selling for this day, but that doesn't mean we're only targeting one milk. Okay, we could be talking about the entire milk category when checking for sales performance. But when reporting to these brands, okay, they need to know how much are they selling, how much their products are performing in our store. So when I report to sino bang owner ng Chucky, I forgot, let's say Chucky Corporation. When I report to Chucky Corporation, I only show them that this is your sales data. Okay, this is how Chucky sells in my store. Okay, or let's say when I go to Selecta, this is how Selecta milk is performing in terms of sales. Okay, so again, different people, different audiences, but again, the point of product dimension is that we have all the descriptors here of the product. Okay, so for example, an example would be, okay, product description: bake light, well light sourdough fresh bread, description, baked well, categories bread. We could have sweetened bread as category. We could have frozen desserts as category. We could also have different departments. So the breads fall under bakery, the frozen desserts fall under frozen foods, okay, and a lot more information. Okay, now what is the use of this? Okay, so technically the use of these additional information is for us to drill down on different levels, right? So for example, if we want to understand um, from a department level, okay, from bakery and frozen foods, we want to know um, which of the brands actually how does each brand perform. Then we can simply add the brand column, and it will actually show us this department and brand performance in terms of sales amount and quantity. Now let's say another analyst doesn't need the brand actually, but let's say he's the nutrition analyst. He wants to know how the different levels of fat content performs, or which ones are actually being bought by the consumers. Okay, so instead of brand, he could actually use the fat content column and see the performance of non-fat products versus reduced fat products versus regular fat products for the bakery department and also for the frozen foods department. Okay, so now probably you're seeing, okay, we could store as much information so that we could get as much insights later on. True, okay, but again, you need to go back to the business and ask what are the things that you want to understand, what are the things that you want to measure, and how do you want to see them. Okay, again, if we go back to the CRISP DM cycle, we are going back to the data, to the business understanding. Okay, now let's say the business user wants to see the sales data from a another example, from a row from a store manager perspective, let's say, pero wala naman tayong store manager data, then it doesn't make sense to make that report, right? So that's how it usually works together. Store dimension, I won't go too much detail. Information about the stores. Okay, so that's why we can capture, some global organizations can capture sales performance from a region perspective, to country perspective, to districts, to cities, okay, and so on. And also for promotion, okay, ad type, coupon type, anything that is related to marketing campaigns. Now, there will be some issues regarding this one. So for example, you can some of the dimensions could be split further into different dimensions. And when we do that, that's actually what we call the snowflake schema, where our dimensions have dimensions as well. At some point, it's useful, okay? At some point, it doesn't, okay? So when we try to split down the tables as far as we could, we're actually consuming more space, okay? So we're actually limiting we're actually reducing the computing resources that we could spend for aggregating these data and moving them to storing these lots of tables. So there's a balance between just focusing on a star schema, okay, which has a central fact table surrounded by dimensions, or if you want to split further, okay, that's actually a business question. This is a business question. How much data do you want to include? And also, we also have what we call the centipede schema. Na-enjoy mo. You're at 3 dimensions. Wow, we could capture so much info. Why don't we add more? So you add. Then you found out that you're actually there's not a lot of dimensions stored or connected to your just one fact table. And now when user pulls in this report, okay, it's now its extraction or query performance is now too slow. Okay, it has slowed down because of these multiple joins. So again, you need to strike balance. The goal of data warehousing is for ease of use and performance. The ease of use from a business user, which may or may not have the right technical skills and also the performance. They would need to have their data as soon as possible. Okay, so we want to optimize that as well. So these are the two common issues when regards to designing a data warehouse. Okay, now that's the sales process. We just talk about the sales process, and I want to discuss other data warehousing concepts using a different process. So let's talk about inventory and transportation. Okay, so when we talk about inventory, so usually the store or the company receives the goods from their suppliers and it inspects them. Okay, once it's cleared, okay, or if it's not cleared, then it goes back to the supplier. If it's cleared, then we create goods receipt, or and also we create a transfer order. Okay, so goods receipt basically records that we receive this amount of this product at this quantity at this time, date and time, right? Also, we create a transfer order to say that, hey, we need these products moved to a warehouse or a different or to a store. Okay, so we stock the goods there, and then the receiving entity will confirm that, hey, we received the goods as well. Okay, now when we release, when these products are ordered, okay, there is an outbound delivery request from the salesman that, hey, we need to release 10 refrigerators, for example. Okay, now we release the goods, we create transfer order, okay, and then we ship the goods to the receiver, or to the store, the salesperson, and then we file a goods issued document. The document says that these amount of products, this product at this time and date has been released from the warehouse. Okay, so these yellow are the documents that stores those information. Okay? You could get so much information from those documents, which is related to inventory. Okay, now we have two inventory triggers: order to cash, which is to check if stock in an order to cash cycle, which is the sales cycle. It triggers the inventory process if they want to check if the stock is available before they conduct the sale. Okay, you might have experienced ordering something and they said that, oh yes, we have stocks, and then later on they said, wala pa pala yung stocks. So that's that scenario is not the optimal. It's not the best customer service that you can get, right? Or the other way around, make to stock. Okay, basically we create the items and then stock them. Inventory process is triggered when the manufacturing team needs to check how much inventory are there. Okay, if the stock needs to be replenished, okay, by the manufacturing team. All right, so common inventory models, we have the inventory periodic snapshot, which is used to ensure that the right products are in the right location at the right time. Okay, so we have the date, the fact usually is quantity on hand, and its granularity could be by day, by product, and by location. Okay, we also have the inventory transactions, which measures the impact of inventory transactions using quantity and financial value. Okay, so for those who have encountered operations management or maybe accounting, okay, you can actually have a financial value beside your inventory level, right? So let's say we have X thousands of pesos worth of inventory in this warehouse and so on. So that's the inventory transaction. Granularity, again, you can view it by date, by product, by location, by vendor. Okay. Lastly is inventory accumulating snapshot, which tracks the disposition of the product shipment until it has left the warehouse. Okay, so what are the difference of this? These are the different fact tables that you can play around with. Okay, so the easiest one is the transactions. Similar to sales transactions, it simply records transaction itself, right? So it stores the lowest granularity of data. Periodic snapshot, okay, it stores the current state of data at the regular interval of time. Okay, so for example, if I am the store manager for the 7-Eleven Ateneo branch, early in the morning, I will print an inventory snapshot to check what is my inventory levels or beginning inventory levels for that day. Okay, at the end of the day, before I close my store, I will also print out another snapshot, which is my ending inventory ending inventory, and then I will use that as a basis to count the products in my store. So to see whether the actual stocks are still aligned with my data. Okay. So that's the periodic snapshot. Now, accumulating snapshot is it stores intermediate steps that has happened over a period of time. So it's more of a historical view of these periodic snapshots. Okay, that's the accumulating snapshot. Okay, periodic snapshot, example of schema. Okay, hopefully if you understand very quickly what happened in the sales snapshot, you can view this. You could use the same principle to view this model. Okay, so we have the fact here, we have the quantity on hand, okay, and the date, the product, the store. Okay, again, example. If I want to check the beginning inventory level, I would simply print out that report, and then it gives me these information. Okay. Inventory transactions would have a different level of data. Instead of inventory on hand, you have the dollar amount. Okay, it responds to the usually to the following questions: how many times we have placed a product into an inventory bin on the same day we pick the product from the same bin. Okay, that talks about some inventory turns. Okay, how many separate shipments did we receive from a vendor and when did we get them? So for example, if we ordered 10 boxes of milk, okay, but then on that day that you requested it, they were only able to deliver 6, then that shipment has been split or separated to 6 and 4 in order to fulfill that order of 10. Okay, so you can see that using the inventory transactions, and also which products has the most number of inspections that caused us to return the product to the vendor. Okay, so earlier in the process, we see that when we receive the goods, we still have to check and clear those goods, whether it's good for us to get them or not. And then we return whatever we reject from those items. Okay, so you can view those information here on inventory transactions. Okay, and lastly is inventory accumulating snapshot. As you can see, it's used in a long-running, continuously replenished inventory process. It provides an updated status of the product in the inventory. So instead of just a simple snapshot of what happened on that day, we could actually store it in a more historical manner, covering also different types of transactions. Okay, you can see here we have multiple date dimensions for different transactions: date received, date inspected, date placed in inventory, date authorized to sell, and so on. Okay, so there's a lot of more information here in the accumulating snapshot. Okay, that's for the inventory. Okay, now let's move to procurement. So procurement, again, going back to the value chain, they actually cover sourcing for products or materials for our organization, whether it's for consumption or for manufacturing. So there are 2 domains of procurement. One is the strategic, where we actually work with the contracting, bidding for as a supplier for our products, and also the operational, which basically requesting for purchase. Okay, so for example, if we have a request for purchase, it files a purchase requisition document, which is, if it's approved, okay, then we transform the purchase requisition into a purchase order. Okay, and then once it's a purchase order, it can actually trigger the sales process of our supplier, which then gives us invoice. Okay, and that invoice will be confirmed on our end again. So once you receive the product, we also look at the invoice for if the products are correct, if the amount is correct, okay, and also if we receive the right product. Okay, so that's why it's called a 3-way match. And then from here, okay, may animation pala to. That's a three-way match. Okay, and then we send the payment once it's confirmed. Okay, so the typical key measures in procurement. So ideally, we are looking at cost savings. Are we purchasing at a reasonable quantity, or are we exercising our purchasing power? Okay, so that's also another thing from a competition perspective. Okay, we need to exercise our purchasing power so that we can get the most optimal price that we could get from that specific transaction. Or another key measure for a procurement department is to minimize maverick or rogue spending. Okay, we from strategic procurement, we crafted this contract with this supplier so that we can minimize or maximize our discount. And if you purchase outside the contract, then the cost savings are not guaranteed. So we need to the procurement team also checks Maverick spending. If it's going above a specific threshold, or then they could actually maybe file a deal with the supplier and then put a contract in it. Okay, or are we still at the right levels of rogue spending? Okay, our purchases are still within expectations, and also we could use this information for vendor performance. So how compliant are they when it comes with the contract that was set? Okay, we have 5 minutes left. That's too much information. I understand. I'm sorry, but again, you can get back to this recording if you would need to get more details. But let me just go through a few more steps. Okay, to explain this, let me give you a quick example. And hopefully it's really a quick one. Okay, can you see my Excel file?
Yes.
Can you see it?
Yes, sir.
Okay, so we have here an example of an aggregated table, okay, that which is extracted directly from a dimensional model. We have the date from the date dimension, the store dimension, the product dimension. I just made it very simple, just one column each. Quantity sold, these are our facts: quantity sold, sales amount, margin, quantity on hand, and tax. Okay. We have here our product dimension, which basically stores our items, unit price, and costing. So I used this product dimension to get the figures for the total sales amount and also the margin. Okay. So now, again, the facts need to be additive. So if we summarize this, okay, using a pivot table, let's say from a date, product, and sales amount, okay, the tool could easily aggregate them, okay, and it still makes sense. Okay, the total sales for all branches is 120. Okay, if we total sales for all products is this one, still at 290. Okay, or let's say if we aggregate them on store, it's still the same. Okay, so transaction facts that are purely additive, transaction facts, okay, are additive facts on all dimensions, okay, which means that they can be aggregated on any dimension: date, store, product. Okay, another type of dimension is semi-additive, which means that these facts are not additive on all dimensions. Okay, so for example, we can see how much stocks are there per branch. Okay, that still makes sense. We have 15 items, 30 items, 17 items. If we do it by product, that still makes sense. Okay, 19, 31, 15. But if we do it by date, okay, this doesn't make sense anymore. It gives us a wrong total or wrong aggregation. So this means quantity on hand is not additive on date dimension. And that means the quantity on hand is a semi-additive fact. Okay, that fact cannot be aggregated on all dimensions. In this case, quantity on hand is not additive on date dimension. That is what we call the semi-additive facts. Now, we also have the non-additive facts, okay, which is if we deal with percentages. Okay, so for example, if we get the VAT, okay, where's the VAT here? Change the source, oops. Okay, if we do the VAT, okay, the VAT shouldn't change from any date or transaction or store. It needs to stick at 12%. But look at what we're having here. It's aggregating it on different dates, okay, from the store and also from a product perspective. So it doesn't make sense. It doesn't make sense because that VAT level needs to be the same at the most granular level. Okay, it has to be 12% for all of these transactions, whatever the store, whatever the product, whatever the date. Okay, that means that, okay, or this specific measure is not additive, but it's still considered as fact. okay, because it's a business measure. Okay, so those are the three types of facts that you can encounter maybe in your project, or maybe in your when you go out in the industry and you were dealing with these types of data. Then you need to understand which ones can be aggregated, which ones can be aggregated at some dimensions only, and which ones couldn't. Okay, because that will affect your reporting afterwards. Okay, it's already 2 o'clock. There are just a few more concepts that I want to discuss, but I can simply discuss this on recording. But for now, I just want to show you very quickly what is happening on Canvas. Any questions in the chat? Or maybe you have questions that you want to voice out? Okay, so this is so yeah, we have the week 3 contents here. I will upload the recording here at the synchronous session page. And just to make sure that you are well aware that week 4 preparation is already here, you need to rely on the metrics that you presented. Okay, ideally that's the purpose of the week 2 presentation, so that you can come up with business questions and what measures you want to track. Okay, just focus on one KPI. Okay, you don't need to deal with all of them unless they are also related. You can do that. It's up to you. If you were not able to lay down your goals and metrics during the last presentation, then you will need to catch up to come up with those KPIs. Okay, come up with categorical dimensions. Basically here, just follow the dimensional modeling process. Okay, you need to have a time dimension, and you need to understand what other dimensions do you want to include in your analysis or your report. Okay, so once you finalize the metric to track, okay, you can look for data online, or maybe just come up with your own data, so it will be quicker. Okay, you can use the structure that I presented earlier, or you can rely on your own insights. Okay, you can just talk about it. What insights do you want to include? And we will be using the SAP Data Warehouse Cloud. Okay, the link is here. I want you to register for a trial version. I recommend only 1 to 2 members would register, because each account will last 30 days. And if you want to use the tool again after 30 days, then you would need a different business account. Business account meaning your Edu accounts. You can use that. Okay, so I recommend just a few members would register, so that you can use the other accounts for to extend your trial. Okay, the playlist, how to deal with Data Warehouse Cloud, I also posted the link here as the playlist. Okay, I will also record my own walkthrough of the tool, which I will upload over the weekend, so you can play around with that. And lastly, I guess the most important thing here is that for week 4, we will not have sessions like this. Okay, but we will allot these time slot for basically the entire week for consultations to help you build that report. Okay, the deadline for the report, I didn't set it yet, but it will be on a later date. So next week will just purely hands-on week. Okay, so no sessions, no recording at all. Okay, that's it that I want to discuss. Okay, also the assignments tab, we have here the business idea pitch. Hopefully by tomorrow you upload all your contents. Okay, basically just whatever you presented. Okay, it's just for documentation. We already have a grade and feedback already based on your presentation. Okay, this is just for documentation purposes. All right, we're over time again, 2:05. I'm sorry, but thank you guys for staying. And if there are any questions, feel free to chat through your BDLs or just message me directly on Canvas. Okay? Any questions?
Sir,
Wala.
can I just ask how the group quiz will go?
The group quiz. Okay, let's go to the quizzes. Basically, okay. Yeah, so just go through the quiz. Just submit one. Just one member will submit on this quiz. Okay? Okay na yun. I have the names. I can distribute the grades using Canvas naman. So this is just a checkup quiz on the data warehousing concepts on page, I think 3.2. Yeah. Oh, is it here for the next one? Modules. Oh, there. 3.4 apparently. So yeah, here on 3.4, right? So I want you to take down these or take note of these terms. Okay, I discussed them here on class lightly, but if you will answer these questions, rely on the ones in the video. Okay.
Okay, sir. So, sir, do we like answer together or?
Uh, I suppose that's up to the group's arrangement already.
Okay, okay. All right.
I'll
Thank
leave
you.
that to you. Just submit by group. That's
Okay,
that's the thing for me.
okay. Thank you, sir.
All right. Okay. Sige, yung mga pahabol questions, just raise it up on Canvas or email. Um, you're very much free to reach out to me also on any other channels if you want. Okay. Yeah, overtime na tayo. So I will end the session soon. Thank you guys for coming in and see you on your consultation sessions. Thank you.
Thank you, sir.
Sir.